Hi everybody, doing the follow-up video on compound interest today. The first video covered the review of compound interest, okay, for compound and continuously compounded interest, how we can use the equations to solve for the final amount, okay, and then we looked at using the equations, reworking the equations so that we can easily solve for the initial amount of the investment, okay, and we did some example problems with that. And then we looked at how we can solve for the interest rate without having using logarithms. Okay, and we did an example problem of that. This video is going to cover how we solve for the interest rate in a continuously compounded interest problem, as well as how we solve for the amount of time that we have to invest money in order to reach some desired amount. Okay, so solving for time in these two problems. And for these situations, we actually need to use logarithms, okay? So the first thing we're going to look for is how we solve for the interest rate in a continuously compounded interest problem. Okay. So once again, the idea is the same. We want to isolate this r over here in our a equals p times e to the rt equation. We want to isolate that variable so it's alone on one side, and we can just plug all of our numbers in on the other side. Okay. So the first step we're going to take is we're going to rewrite it so my r is on the left side. I just do that for myself, okay? I like it when my r is on the left. P e to the rt equals a. Okay. So the outermost operation happening to my r right now would be this p, okay? So I'm going to start by dividing both sides by p. Divide by p. And we get e to the rt equals a divided by p. Okay. And now what we have to use, okay, is we have to use our natural logarithm identities. Okay. If we remember natural logarithm identities, we can have, if we have e to the x equals y, we can rewrite that is the natural log of y is equal to x. Okay? Simple as that. Simple as that. So what we're going to say in this situation, y, okay, our equation right now is in the form of the left side, okay? X is rt and y is a over p, okay? So we're going to rewrite it in the form of the right side. Y is a over p, so I have ln of a over p is equal to x, which is rt, r times t. Oh, cool. So now I have r times t over here. Okay, I'm solving for r, so all I gotta do is divide both sides by t. Divide by t, divide by t, and we have ln of a over p over t equal to r. Boom. There's our beautiful new equation, everybody. Now we can use our natural logarithms, okay? We can use our natural logarithms to solve for interest rate now. So let's take a look at this example problem. Maddie invests $6,600 in a savings account with a fixed annual interest rate compounded continuously. After 10 years, the balance reaches $13,310. What is the interest rate of the account? So since it's compounded continuously, I'm going to use this equation over here. Okay. Let me zoom in a little bit. Make it easier on myself. Okay. So we're going to say r is equal to the natural log of a over p divided by t. Okay. We're going to have to put in a p, and a t here. Those are the three variables we need to identify so we can solve for r. Okay, so a is equal to our final amount, 13,000 310. P is our principal amount, which is 6,600, and T is the amount of time, 10 years. Okay, so now we're going to solve for our interest rate R. Let's plug in all of these numbers. R is equal to natural log. We have 13,310 divided by 6,600. Let's just redo that one. 600. And that's all divided by time, which is 10. Boom. R equals some expression with a bunch of numbers in it. Let's grab our handy dandy calculator and plug it all in. Okay. So you don't hit the natural log button first. I have to hit a second. Okay. So 13,310 divided by 6,600 equals natural log divided by 10, 0.07. That sounds like a pretty reasonable interest rate. R equals 0.07 equals 7%. Good job, team. Good job, team. Cool. All right. And the last thing that we're going to use logarithms to solve for is when we're trying to find the amount of time it would take in order for our initial investment to reach some amount, some final amount, given an interest rate and maybe even for compounded interest on an interval. Okay. So in this situation, we're solving both of these equations for t. Solving both of these equations for t. And you'll see the process is going to look quite similar to how we solved the previous equation for r. Okay. Let's actually do the continuously compounded one first because it's a little bit simpler and easier to look at. Okay. So we're starting with. Oops. All right. So we're starting with a equals p times e to the rt. Do the first step the same, divide by p on both sides. Okay, and we get a over p equals e to the rt. We're going to apply that same process again. E to the y equals, it's e to the x equals y, right? E to the x equals y goes to ln. Let's do x equals ln y. Okay, so once again, our x is rt, and our y is a over p. Okay. So when we rewrite our equation, we get rt equals ln of a over p. Make that p a little cleaner. P. And then to solve for t, we just divide both sides by r. T equals ln of a over p divided by r. Okay? Simple as that. Let me grab this guy. Oh, that's not going to work. We'll leave it right there. It's the perfect place for it. It's the perfect place for it. We'll give ourselves a little box. Okay, so there's our equation solved for t. Let's take a look at the other one. It's going to take a little bit longer to get to. It's a little bit more complicated. Okay, but we're going to get there anyway. So a equals p 1 plus r over n to the nt. Let's copy it down. Start by dividing by p on both sides. I get a over p equals 1 plus r over n to the nt. Okay, and our t is up in this exponent again. All right, so we're going to use our properties again, our properties of logarithms. Okay, if we have log base a of x equals y, okay, that changes to be a to the y equals x. Okay, so in this situation, a is 1 plus r over n, y is nt, and x is a over p. Okay, so we're going to apply this property to rewrite from this form on the right to the form on the left. Okay, so we have log base a, the base a is 1 plus r over n. 1 plus r over n. That's our base, okay? And the argument of our logarithm x is a over p. And that is all equal to y, which is just nt. Okay? And then what we're going to do to solve for t here is we're going to divide by n. Okay. So now we have log base 1 plus r over n of a over p divided by n equals t. Okay? Told you guys this one was a little bit uglier because now we have log that's based with this weird thing, right? Can we calculate? I can't ask you guys a question. You're not here. We can't actually calculate this, okay? The only thing that we can calculate on our handy dandy calculator, if we look at the buttons, is we have log and we have ln. Okay, natural log. Ln is natural log. That's base e. Okay, it's that special one over here. And then this log is base 10. Okay, so what we need to do is use the change of base formula so we can actually calculate what this guy is going to be equal to. Okay, I'm just going to write change of base here. Okay, change of base formula, this is one that says we can rewrite our log that has some silly base as log of whatever, log base 10, which is just log of a over p divided by, and we're going to divide it by log of this thing. Okay, now we're already dividing by n, so I'm going to write n in front, then log 1 plus r over n. Okay, that's going to be t. Change of base, so log of a over p divided by log of 1 plus r over n. Both of these logs are the standard logs, log base 10. Okay, so now we've got our formula for this guy. We've got our two formulas again. Okay, let's take a look at our last problems that we're going to solve. Two examples of this one. Oop. All right, here we go. Two examples. Let's knock them out. So, on the left, Joel invests $8,300 in an account that pays an interest rate of 4% compounded monthly. Compounded monthly. Okay, so I'm going to go ahead and underline that so I remind myself I'm talking about monthly compounding. How long will it take for his account to reach $12,000? All right, he's got lofty goals. All right, so let's start by copying down our equation. T equals log A over P over N times log 1 plus R over N. Okay. Got our equation written down. We want to identify A, P, R, and N. My A is my final amount, that's 12,000. P, initial amount, 8,300. R is interest rate, that's 0.04. And N is monthly, so that's 12 times per year. So we have our equation written out for T here, so we can write T is equal to, plugging in my variables, log of 12,000 divided by 8,300 divided by N is 12 times log 1 plus 0.04 divided by 12. Ooh, boy. That's a wacky one, huh? It's really complicated and gross looking. You know what, for this one, I'm going to go ahead and plug, I'm going to show you guys another website I like to use to help me out with calculations. It's called Wolfram Alpha. And it's really nice. It lets you type out all of your expressions and everything, and it tells you a lot of information about what you're plugging in here. And it's also just a lot friendlier to use in a calculator because it does all of the order of operations work for you. Okay, so I'm just going to type in this expression exactly like I see it. I'm doing log of 12,000 divided by 8,300. And then that whole thing is divided by, I'll open some parentheses, 12 times log, open parentheses, 1 plus 0.04 divided by 12, close parentheses, close parentheses. It's highlighting it for me. That's really nice. It tells me the answer is 9.231. Awesome. All right. Only takes this guy 9.5 years to make his money, guys. All right. Let's take a look at this other problem over here. Do the continuously compounded version. Over here we have Wilbur invests $6,910 in a retirement account with a fixed annual interest rate of 6% compounded continuously. How long will it take for the account balance to reach $15,090? Okay. Let's go ahead and copy down our equation that we found. T equals natural log A divided by P divided by R. We need to know A, P, and R in order to identify our time here. Okay, so my A final amount, 15,090. P initial amount, $6,000, 910. And interest rate 6%, 0.06. Let's go ahead and plug that in. T equals natural log 15,090 divided by 6,910 divided by 0.06. This one's going to be a lot easier to plug in. Let's go back to Wolfram Alpha just for fun. Okay, we have the natural log 15,090 divided by 6,910, and that's all divided by 0.06. And it looks like the answer is 13 years and change. Okay, I'm just going to say it's 13 years. Let's say 13 years. Okay, T equals 13 years. All right. Hope you guys all enjoyed these videos. I hope they were helpful. I'm going to post all of these notes online in PDF form also, so you don't have to watch the video to get all the information, okay? So thank you, everybody. Enjoy.